Hi! So today in this video we're going to be going over 1015's chapter 2.7.1, which is talking about systems of linear equations in three variables. This one will not deal with as much with solving these systems of equations, more with talking about some of the things that it involves. Now, similar to our previous video where we talked about independent systems, consistent, independent, inconsistent, and inconsistent systems, a very similar thing happens in this as well. Again, it's going to be an a dependent system, independent consistent system if all three lines are the same. That means that you have infinitely many solutions. And usually this will give you 0 equals 0 again. There's also going to be basically the same where it's like there's consistent and independent where all three lines intersect at like one point. That's going to be your consistent independent solution, as very similarly to our beginning. And then there could be like three parallel lines where none of these lines intersect ever will intersect, and that's going to be your inconsistent system, which will be no solutions. So now what we'll do with this one, it's asking us, is the ordered triple 3, -3, 1 a solution to the following system? Now, just a refresher, when you have two coordinates, x, y, right? When you have 3, it stands to reason that you'll have x, y, z. And so what we can do is we can plug all these points in and see if it works. So -3 minus -3 plus 1 equals 0. This will turn into 3 plus 3. That gets rid of this. Plus -1. -1 does not equal 0. So our answer is going to be no. You could try this with any of the other problems too. So you could get 6 times 3 plus -3 plus 5 times -1 equals 10. That would give you 18 minus 3, which is 15, minus 5, which is 10. So that one works, but that doesn't mean that it's a solution because our first one didn't work, right? So now we'll try the bottom. So we'll get 3 times 6, which is 18, plus 3 times -3. That's also why it's important to test all 3 points, by the way. You could have 2 that work and 1 that doesn't. Plus 2 times -1 equals 7. That gives you 18 minus 9 minus 2, which will give you 9 minus 2, which is 7. And so these two bottom ones work, but the top one does not work because -1 does not equal 0. So it is not a solution to our following system. This one is saying a system that you are solving is dependent. Select all of the following statements are true. Now remember, dependent is when the line is completely the same, right? So it will lead to an identity. The system defines 2 or 3 planes whose intersection results in either a line or a plane. I think it'll be the second one. I had green on it, and I think it should be this one. So it defines 2 or 3 planes whose intersection results in either a line or a plane, which is like this, yeah. So yeah, I think those two should be correct. It's not a contradiction because dependent will have many solutions, and all of the planes will intersect sort of because they're all the same, right? And then this one, a system that you're solving is dependent. Select the following statement that is true. Oh, I think this is exactly the same with the answers. Yeah, so this was correct. The first and the third are correct. A system that you're algebraically solving results in a contradiction. Select all the following statements that are true. The system has infinite solutions. Nope, that's not it because it doesn't have any because it's a contradiction, right? It's not consistent or dependent. The system is represented by 3 planes that meet in a line. No, the system is going to be inconsistent. It's not going to be consistent. and it's going to be represented by 3 planes that have no points in common, and the system also has no solution. And that checks out. If you remember, contradictions have 3 parallel lines, basically, lines that will never intersect. And then this last one, I don't have an empty one, but basically this is asking us that have 3 planes that intersect in a line, right here. And so it's a dependent system. Yeah. Hold on. One moment. Okay, actually, this one, the wording is what gives it away. So it's not actually intersecting at a point. It doesn't say that. It says that intersect in a line. So it's all going to be one line, right? So, and if you remember, the one line means that it is dependent. It does not lead to a contradiction because there are solutions. Solving the system leads to an identity, which is going to be that line, and the system has infinitely many solutions. And it is not inconsistent, because it is consistent. It has solutions. The system has more than one solution. It has infinitely many solutions, and the system has no solutions. That's not true either because it has infinitely many solutions. Yeah, so this one's a little bit tricky. It's just knowing what inconsistent and consistent and dependent and independent means when we're talking about these 3 lines. It's going to be pretty much exactly the same as our last video where we talked about inconsistent, independent, consistent, and dependent things. So yeah, if you have any questions, please let me know and I'll answer as soon as possible. Have a good one.